You know, there's a specific kind of envy I get when I see a really well-maintained aquarium or a garden pond.
Hmm.
It just looks so peaceful, so perfectly still.
Like whole Zen aesthetic, right?
Yeah.
Everything in perfect balance.
Right. But anyone who has actually tried to keep a body of water alive knows that peaceful is usually a lie.
Oh, it's a constant war zone.
It is. It's chemical warfare. And the thing that freaks people out the most is how fast it can all turn.
Yeah.
I mean, you can have a pristine pond on Tuesday, clear water, happy fish, and by Wednesday morning, literally overnight, the entire surface is just gone. Erased, covered in this solid, bright green carpet.
It feels almost aggressive, like a magic trick, or maybe some kind of environmental disaster on fast forward.
Exactly. And usually the reaction is just panic. You grab a net, you start scooping, you buy chemicals, you scream at the sky.
Been there.
But today, we're going to do something a little different. We're going to look at that green explosion, and we are not going to panic. We're going to debug it.
Debug is the perfect word for this.
It really is. Because for this deep dive, we're looking at a fascinating set of observations from a blog called keynm.org.
Okay.
The specific post is titled Notes on Fishkeeping, Part 175. Decoding Duckweed Explosions in Tropical Ponds.
Part 175.
Yeah.
That should give you a clue about the kind of mind we're dealing with here.
Oh, absolutely. The author, Ang, he describes himself as an old software plumber.
Ah, I love that.
And that one description, it just completely reframes how you read this. He's not a botanist. He's not an ecologist.
Right. He's a guy who spends his life fixing broken code, probably in languages like, Elixir or Erlang, based on his blog.
Yeah, exactly. Which are very systems-heavy languages. They're all about concurrency, fault tolerance, keeping massive systems from crashing.
And he's taking that exact same systems architecture mindset.
And pointing it at a layer of green slime in his backyard.
It's a fantastic perspective. Because when a software engineer sees a bug, like a system crash or an infinite loop, they don't just say, oh, bad luck. No. They know there's a cause. There's an input that triggered an output.
And Ang looks at his pond the exact same way. That duckweed explosion isn't random, it's a subroutine that just got executed.
So our mission today is to walk through that code. We're going to figure out the mechanics of this duckweed subroutine. We're going to look at the biological hardware, these little floating plants, and understand how they pull off this magic trick of appearing overnight. And we're going to follow Ang's detective work to figure out why it's happening right now.
And to do that, we have to start with the hardware itself. The duckweed. Because what you see on the surface, that's only half the story.
This was the first big aha moment for me in the reading. Ang points out that he doesn't, keep a spreadsheet of the growth or anything.
Right.
But he has noticed a pattern over, as he puts it, many moons. He says the species suddenly emerges from dormancy to carpet the entire surface. But that key word there is emerges.
Right, emerges from where?
Exactly. If the surface was clear yesterday, where were they all hiding? They didn't just fall from the sky. They were underwater.
And this brings us to probably the most sci-fi sounding term of the episode.
Oh, sure.
Turions.
It does sound like something from Star Trek, doesn't it? Captain, fire the turions.
It really does. So break this down for us. What exactly is a turion?
So a turion is, it's essentially a survival pod. It's a dormant bud that aquatic plants like duckweed produce.
Okay.
When conditions get tough or when the plant needs to conserve energy, it basically disconnects this little bud. It's dense, it's heavy, and it sinks.
So it's a bunker strategy. The plant is basically saying, hey, surface life is getting dangerous. I'm going to the bottom.
More precisely. They settle down into the sediment, into the mud at the bottom of the pond, and to your eye, they've just disappeared. The pond looks clear.
But the floor of the pond is actually seeded with these things.
It is. It's seeded with all these sleeping buds just waiting for a signal.
And this is where the mechanics get wild. Ang describes how they wake up. He says they begin to metabolize.
Right.
And as they do that, they fill with gas.
I mean, think about the physics of that for a second. It is pure engineering. The bud is heavy, so it sinks.
Yeah.
But it needs to get back to the surface to photosynthesize.
That's right. It's a plant. It needs light.
It needs light. It has no legs, no fins. It can't swim. So how does it get up there?
It builds its own balloon.
Basically, yeah. When it detects the right conditions, it kicks its metabolism into gear. One of the byproducts is gas oxygen, other respiratory gases.
Yeah.
And normally a plant would release that. But underwater, that gas gets trapped inside the tissues of the bud.
It's literally blowing its own ballast tanks.
It is exactly like a submarine. The gas makes the bud less dense than the water. It becomes buoyant. and then ping it, just shoots up to the surface.
That image is so cinematic. You have this clear, empty-looking pond, and then silently, thousands of these little green submarines just release their brakes and rush the surface all at once.
And that's why it looks like an explosion.
Yeah.
It's not one plant dividing into two and two into four, which takes time. This is an entire army surfacing simultaneously.
That explains the overnight part. It wasn't growth. It was arrival.
Yes.
But here is where Aang's observation gets really nuanced. He catches a bug in the logic. Or, well, a discrepancy in the environment.
And this is the difference between reading a textbook and actually, observing nature in your specific context.
Right. Because typically, this turion strategy, this sinking submarine thing, that's a winter survival mechanism, isn't it?
Correct. If you're a duckweed plant in, say, Germany or Canada, surface life in winter is a death sentence. The water freezes solid.
Your cells would rupture. Game over.
Game over. So you sink to the bottom where the water stays liquid.
Right, because water is densest at about 4 degrees Celsius, so the bottom of a frozen pond is actually warmer than the ice on top.
Exactly. You sink to stay warm, you wait out the winter, then spring comes, the water warms up, you metabolize, make gas, and float back up.
Standard operating procedure. But Aang isn't in Germany. He's in the tropics.
And the tropics don't have a freezing winter.
So why does the duckweed still have this code? Does it just run the winter subroutine by mistake, or is something else happening?
And this is what's so cool about his note. He observes that in the tropics, the behavior is different. It's like a fork in the code.
He calls it partial dormancy.
Yes.
Yes.
He notes that instead of sinking all the way to the bottom, the duckweed in his tropical ponds just changes state. He describes them turning small and yellowish.
But they stay floating.
They stay floating. And you have to ask why. Why would it change the strategy?
Well, I guess if there's no ice, you don't need to hide at the bottom.
It's more than just don't need to. It might actually be dangerous to sink in the tropics.
How so?
Well, in a tropical pond, the water is warm. Warm water holds less oxygen than cold water.
Right.
And the bottom of a warm pond is often where all the decomposition is happening. The bacteria down there are working overtime, breaking down fish waste, leaves, and using up all the oxygen. It can become anaerobic.
Oh, I see. So the bottom isn't a safe bunker anymore. It's a dead zone.
It could be. It could be full of hydrogen sulfide, other toxic byproducts from those anaerobic bacteria. If you sink into that mud in the heat of the tropics, you might just suffocate or rot.
So the plant adapts. It keeps the dormancy part. It stops growing to save energy.
But it deletes the sinking part.
Exactly. It enters a low power mode. Turning yellow means it's breaking down its chlorophyll.
Right. It's stripping the copper out of the walls, shutting down the factory, and just drifting. It's idling.
It's waiting.
It's waiting.
Which brings us to the detective story. Aang has these idling, yellow, partially dormant plants, and then all of a sudden they wake up. The explosion happens.
The subroutine executes.
And being the software plumber that he is, he wants to know what button got pushed. He wants to find the trigger.
And this is where you really see that debugging mindset in action. He doesn't just guess. He isolates the variables.
He identifies 2 main suspects for triggering growth in his region. Variable 1, the monsoon cycle, so basically rain.
Okay.
And variable 2, nutrient levels.
The classic A/B test.
Let's look at the rain first. Why would a monsoon trigger a plant explosion?
Well, rain is a massive disruption. In nature, a big rainstorm does a few things. It cools the water down, which increases oxygen. It agitates the surface. And usually it washes runoff from the land into the pond.
Which brings in fresh food.
Exactly. Fresh nutrients. So biologically, a storm is a dinner bell. It's a go signal. Conditions are changing, time to grow.
But Aang looks at his setup and he rules this out, immediately.
How does he do that?
He just notes that his outdoor ponds are sheltered. They have a roof. They're protected from the heavy rain. So if the duckweed exploded but the rain input was 0.
Then the trigger couldn't have been the rain. Variable 1 is eliminated.
Which leaves us with the only other suspect. Variable 2, nutrients.
The food source within the pond itself.
This seems logical, but I want to dig into how that happens. I mean, if he didn't just dump a bag of fertilizer in there, how do nutrient levels just rise on their own to trigger this explosion?
That's the invisible part of the fish-keeping cycle. Fish eat food. Fish produce waste. That waste is ammonia. Then you have beneficial bacteria, in the filter or in the pond slime, and they convert that ammonia into nitrites, and then into nitrates.
It's a nitrogen cycle.
Right. And nitrates are, for all intents and purposes, plant fertilizer. So if you have fish swimming around pooping every day and you aren't changing the water constantly, that nitrate level is just slowly, silently creeping up.
It's like a counter incrementing in the background.
Exactly. Nitro level plus add. It just keeps going up day after day. The water might look crystal clear, but chemically, it's becoming a nutrient soup.
And the duckweed is just sitting there in low power mode, sensing this.
It's monitoring the variable. And Ang deduces that once it hits a certain threshold, the plant switches from idle to execute.
He says, since my outdoor ponds are sheltered from heavy rain, the primary driver must be nutrient availability. It's just such a clean deduction.
And he backs it up with data. He doesn't just say nutrients. He contextualizes it with the Goldilocks zone for these plants.
Right. He lists the optimal conditions. He says the pH needs to be between 6.5 and 7.5.
Which is right around neutral. Most freshwater fish love that range, too.
And the temperature range is massive, between 17 and 35 degrees Celsius.
That is a huge range. I mean, 17 is chilly, 35 is almost bathwater. That tells you these plants are incredibly resilient. They aren't picky about heat. They're picky about food.
And here is the synthesis that I thought was brilliant. Ang mentions he has multiple ponds. But he saw this explosive growth in one specific pond.
That's the control group logic.
Exactly. If it was the ambient temperature or the humidity or, I don't know, the phase of the moon, all the ponds should have turned green.
But they didn't. Only one did.
So he knows with near certainty that that specific pond hit the nutrient sweet spot.
The pond itself became the petri dish.
It totally changes how you look at the green slime, doesn't it? We usually think of algae or duckweed as dirt, as a sign that the pond is failing.
But Ang is arguing the opposite. He's saying the duckweed is a dashboard notification.
A dashboard notification, I like that.
Yeah, if you have a server and the CPU usage light starts flashing red, you don't smash the light. You say, oh, okay, the system is under load.
So the duckweed is the flashing light.
It's the system throwing a flag. System alert. Nutrient load high. Conditions optimal. The plant isn't attacking the pond. The plant is responding to the success of the pond's own nutrient cycle.
It's a feedback loop.
A perfect biological feedback loop. You don't need a chemical test kit to tell you your nitrates are high. The duckweed is screaming it at you by covering the surface.
And you can hear his reaction in the text. He isn't frantic. He isn't rushing to scoop it out. He's just decoding it. He writes, judging by the explosive growth, I assume the environment has reached the optimal conditions.
It's so detached. Very scientific.
It brings us back to that part 175 in the title. We touched on it, but I want to dwell on the whole notes on fish keeping aspect.
It's a staggering amount of documentation.
And it's not just fish keeping. I was looking at the sidebar of his site, kianm.org. It's this list of obsessions. Notes on gardening, notes on photography, notes on elixir, notes on rust, notes on dieting, notes on guitar.
Notes on home improvement. I saw that one.
This is a guy who documents everything.
And I think that's the secret sauce here. That's why he can spot the difference between tropical dormancy and winter dormancy.
Right.
That's why he can rule out the rain.
Because he has the data set.
He has a long now perspective. You know, in software, there's a difference between a junior developer and a senior architect. A junior dev sees an error and just fixes that error.
Right.
A senior architect looks at the code and sees the history. Oh, right, we wrote this module 5 years ago to handle X, and now it's interacting with Y.
They see the patterns over time.
Ang has many moons of fish keeping, as he puts it. He has a longitudinal database in his head. He might not be using a spreadsheet, but he has the intuition that only comes from years of consistent observation.
He even mentions that. He says, I don't strictly track growth, which I found kind of comforting. You don't have to be a robot to be a scientist.
No, but you have to be present. You have to be paying attention. You don't notice that a tiny yellow leaf is partially dormant if you just glance at a pond once a month.
No.
You have to be staring at that pond while you're debugging code in your head day after day, year after year.
It connects back to that idea of legacy code. A pond is basically legacy code. It's a complex system running on hardware you didn't build with inputs you can't fully control.
And sometimes, yeah, it executes a subroutine you didn't expect.
And instead of getting angry at the bug, you analyze it.
That's the shift. That is the software plumber philosophy applied to life. If he had quit fish keeping after note number 10, he never would have understood this nuance. He would have just seen a messy pond. But knowledge transforms the mess into data.
Okay, so let's zoom out a bit, because
Yeah.
I'm guessing most of our listeners don't have a tropical fish pond in their backyard.
Probably not.
And they probably aren't Elixir programmers, so why does this matter? What's the takeaway for the person stuck in traffic, or managing a team, or just trying to keep their house plants alive?
It matters because we all live in environments that are constantly giving us signals, and we are usually terrible at reading them.
Give me an example.
Okay, a work scenario. Say you have a team member who's been quiet for months, just doing their job, head down. Dormant, we could say.
Idling, low power mode.
Exactly. And then suddenly, one day, they explode. Maybe they quit. Maybe they send a massive angry email. Maybe they suddenly propose a brilliant new project.
The duckweed explosion.
Right. And the typical manager reaction is, whoa, where did that come from? That was so random.
Must be the weather.
Yeah, must be a mood swing. But Ang would say, no, nothing in a complex system is random.
What was it, the turion?
What was the dormant variable?
Was there a slow buildup of frustration, like the nitrates? Did a specific barrier just get removed, like the rain shelter? Did they finally hit their Goldilocks zone of confidence? It's about moving from this is magic or this is annoying to what was the trigger?
It's the difference between being a victim of your environment and being a debugger of your environment.
A debugger of your environment. I love that phrasing.
Ang didn't create the duckweed explosion. He can't command the duckweed to stop, but he isn't surprised by it, and he's not controlled by it because he knows the inputs. Rain, nutrients, pH, temperature.
He knows which buttons work.
And that gives you predictability. If you know that dumping fish food into warm water creates duckweed, well, you can choose to do it or not. You have agency.
It empowers you. You stop treating the events in your life as luck and start treating them as outputs.
And you can even appreciate the elegance of it. I think that's the underlying tone of Ang's post that I really enjoyed. He isn't angry at the duckweed. He's impressed by it.
He respects the biology.
He calls it optimal conditions. He's looking at this green mess and he's thinking, wow, look at how efficiently this system capitalized on the available resources.
That is a great mental reframe. Instead of my pond is ruined, it's my ecosystem is highly productive.
Exactly. Look at my nitrate conversion rates.
So we've gone from a mysterious green carpet to underwater gas-filled buds, these biological submarines. We've differentiated between winter survival bunkers and tropical low-power modes, and we've debugged the water chemistry of a backyard pond using the logic of a software engineer.
Not bad for a 300-word blog post.
It really just shows how much depth you can find in the simplest observations if you're willing to look.
And if you're willing to write down 175 notes about it.
A serious commitment. But hey, that's the deep dive way.
It is.
So here is my challenge to you, the listener. The next time you see something in your world change overnight, whether it's a sudden trend in your industry, a mood shift in your household, or even just a literal weed in your garden, don't just react to it.
Don't just scoop it out.
Ask yourself, what was the turion? What was lying dormant just beneath the surface?
Yeah.
And what hidden variable just shifted to wake it all up?
Was it the nitrates? Was it the temperature?
Because if a software plumber can decode an ecosystem by treating it like a system with inputs and outputs, imagine what you could decode in your own life if you just stopped looking at the surface and started looking for the hidden variables.
The code is always running. You just have to learn how to read it.
Thanks for diving in with us today.
Always a pleasure.
We'll see you on the next deep dive. Stay curious.